Hello students, today I am going to discuss about Hoffmann elimination reactions. Okay, what is Hoffmann elimination reactions? Elimination reactions of 4-degree ammonium salt or quaternary ammonium salt is known as Hoffmann elimination reactions. Okay, what is 4-degree ammonium salt or quaternary ammonium salt? Let me write. Suppose you are given this salt, right? This is 4-degree or quaternary. Okay. Nitrogen has 4 carbon, 1, 2, 3 and 1, 4. Okay. If I do the reactions in presence of base, heat it up, then what will happen? Beta E2 eliminations are E2 eliminations. E2 eliminations are key. In E2 eliminations reactions, this OH minus grab this proton, formations of double bond, and NR3 will leave. So what we will get, beta? We will get simply alkene plus R3N. This is tertiary amine plus water. Okay. Now look at this mechanism. First of all, this mechanism proceeds via E2. Simultaneously, this OH minus grab this proton double bond formations and simultaneously NR3 leave. This is concerted process, single step process. Okay. What are the conditions? There must be the beta hydrogen present. There must be beta hydrogen. So beta hydrogen must be there. Beta hydrogen. Say this carbon is alpha carbon, this carbon is beta carbon. Okay. Second conditions, this beta hydrogen and NR3 plus must be in anti positions. What? Which positions? Anti positions means anti periplanar positions. Okay. Like how anti periplanar positions. Means if hydrogen will be here, then NR3 must be here. Don't do like if hydrogen present here and NR3 here, don't do the E2 elimination reactions, because that will be the syn elimination reactions, and in this case syn elimination reactions is not valid. It will be basically anti elimination reaction. Okay. Now we can get two types of alkene. What? Two types of alkene. Two types of alkene. We can get, we may or may not get. If we get two types of alkene, means there will be two beta hydrogen. In Hoffmann elimination reactions, the less substituted alkene will be our major product and more substituted alkene will be the minor product. But less substituted alkene will be the major product and more substituted alkene will be the minor product. Okay. Now I am going to show you the less substituted alkene and more substituted alkene from a particular amine by doing the E2 eliminations, I mean Hoffmann elimination reactions. Please check this one. Okay, let me start with a specific example. Example start. Okay, by you have given a particular amine and you have given 3 mole CH3 I AgOH and heat. Okay, in the first step, what will happen? Beta, in the first step, basically, okay, let me write this substrate NH2. Okay, CH3I. Nitrogen and lone pair attack and iodide will leave. So what we will get? Basically, we will get beta. Okay, I minus. This I minus grab this proton and form this amine plus Agi. Okay, in the next step what will happen? Again this nitrogen lone pair will attack this carbon, iodide will leave, and we will get okay, we got 3-degree amine. Okay, this process is basically known as Hoffmann exhaustive methylation. In Hoffmann exhaustive methylation, what we will do, we'll be given one particular amine and we will add excess alkyl halide, and we will be getting the tertiary, 4-degree ammonium salt or quaternary ammonium salt. Still it's a 3-degree. Okay, so 1 mole CH3 I consume, 2 mole, 1 mole will again react with this one. Okay, is it clear? Okay, let me write. Okay, this is the quaternary ammonium salt or 4-degree ammonium salt. I get it. Now what will happen? We have given AgOH. So what will happen? This I minus, this counter ion will react with Ag plus, means it will form a precipitate of Agi, and I minus get replaced by OH minus. Okay, write that one. So NMe beta Me, this is plus, okay, OH minus plus Ag I precipitate. Done. I've got it. Now from here we can do the E2 elimination reactions. Please check it. Done. Okay, now I'm going to do the Hoffmann eliminations reactions. Okay, what we have got? We have got basically NMe3 plus and OH minus. Hit. Now in order to do the elimination reactions, E2 elimination reactions, we need to find the beta hydrogen. This is alpha carbon, this is beta. So there are 2 beta hydrogen here and there are 3 beta hydrogens here. So what will happen? This OH minus, either it could grab the proton here and double bond formation takes place here and Me3, or else there will be one more path, like proton grab from here, double bond formations here, and Me3n will be here. So we will get basically 2 types of alkene. Okay, let me write that. This is one alkene and this is another alkene. Okay, this is the more substituted alkene. This is the less substituted alkene. Beta, more substituted alkene. This is hydrogen, this is hydrogen, this is di-substituted, right? And this one basically one hydrogen here, 2 hydrogens are present here. So this is metamer monosubstituted alkene. And Hoffmann elimination reactions in this, quaternary ammonium salt, this will be my major product. This will be my major product and this will be my minor product. Okay, done. So this is the major product, this is the minor product. This is basically known as Hoffmann elimination reactions. Now questions can arise that why the less substituted product will be the major product and more substituted alkene will be the minor one. In order to explain that one, first you just look at the structure. Okay, here you can see that there are 2 types of beta hydrogen. This is the beta hydrogen, this is the beta hydrogen. See, OH minus preferentially grab that proton which is more acidic. Now if you look at here and here, which one will be the more acidic? Say this is 1 degree carbon and this is 2-degree carbon. This will be of course the more acidic. In order to know that okay, suppose you just write like here conjugate base, okay, and Warmond conjugate base you can write here NMe3 plus you can get this conjugate base. Okay, now if I ask you which one will be more stable, this one or this one, after grabbing this proton the conjugate base will form like this one for this one, and after grabbing this proton the conjugate base will be like this one. If I ask you which one will be more stable, this one or this one, of course this one. Why? Because this conjugate base is very unstable due to Plaza effect, of CH3 alkyl group. So this carbanion will be the less stable and this is the more stable, and that's why proton preferentially, I mean OH minus grab preferentially proton from this side and major product will be this one, that is less substituted alkane. This is the reason behind it. Okay, please check it. Okay, done. Okay, now next proceed with one more example. Okay, this one, like we need to do the Hoffmann elimination reactions for this particular amine. In order to do so, okay, let's start with this one. Like previous example, exactly bhai ager moto koro. এখানে কে দিয়েছে 2 mole CH3I. So CH3I, nitrogen and lone pair attack, I minus, leave, then HI, leave. In one step I will write HI. Then what we will get? Basically beta, we will get this is Me, this is my Me. One more CH3I. Then what we will get? Nitrogen and lone pair attack. Okay, will be getting N plus this is Me, this is Me, this is my CH3. Up to this it's okay. So we will be getting this quaternary ammonium salt. Now in the second step, Ag2O is given. This will be basically moist Ag2O. So what will happen? This I minus get replaced by Ag, as Agi means from this I minus will get replaced by OH minus. কি করা ভাই? Ag2O basically react with I minus, a form of precipitate of Agi plus AgO minus. This AgO minus react with H2O to produce AgOH plus OH minus. Okay, we have got the OH minus. Now in the next step what will happen? In the next step we just write Ag2O moist, then we'll be getting like this one, Me, this is my Me and this is my counter and OH minus. Now you just look at the beta hydrogen. Here beta carbon, so beta hydrogen is there, I mean C, this is H, this is H, this is H, and alpha beta, this is, there are also 2 more beta hydrogen. So 2 beta hydrogen, here 3 beta hydrogen. Which one will be more acidic? 1 degree and this is 2 degree carbon. So this will be the more acidic. Okay, so preferentially OH minus grab proton from this side, double bond and like this. So what we will get? We will be getting this amine. Okay, no problem. So we will be getting this amine. Again it will be treated with CH3I. So first you just look at this one. Okay, no problem, pakka, chalo. Okay, now let me write this amine. CH3I, AgOH, OH minus, right? Done. Now, OH minus can grab the proton. Only one option is available here. Like this is the beta carbon and these are the beta hydrogen. So OH minus grab proton from this side, and what we will get? We will be getting beta, this one. Here AgI you just write. So this is the product. Okay, initially how many carbons are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Done. So this is my alkene. Done. So like that way you need to do the Hoffmann elimination reactions. For your information, I will tell you one thing. Hoffmann elimination is also known as Hoffmann degradation reactions. Hoffmann degradation reactions. Okay, no problem. Okay. Done. Okay. Now next move to this one. Very interesting example. This example is very interesting example. Why this example is given? See, when I was doing the Hoffmann elimination reactions, I told you in the first slide that H and NR3 plus must be in antipositions. Okay, then only elimination reactions will take place. So here you just look at this structure. Okay, I will draw the structure again for you. Okay, Me OH H dash in Me3 OH, and here Me dash, so H must be on OH. Okay, now what will be the product? Say, in order to do the elimination reactions, H and NMe3 must be in the antipositions. So this NMe3 OH, so H must be on the dash. So this is the, from this side, OH minus grab proton from this side, not from this side, because H and OH both are on the OH. OH আছে হবে না, so এখান থেকে not possible. So what will be my product? The product will be basically, it's like this. This is my Me, okay, this is my Me3n plus H2. Done. So this is my product. Okay, no problem. Okay, you can write here OH. Okay, done. Okay, now next move to this slide. See, while less substituted product is the major product. See, two ways you can explain. One is, one factor is based on acidity. Means most acidic H plus grab by base, I mean OH minus base, or one more reason, that is static factor. See, transition state, in the transition state, steric repulsions must be minimum. I'll show you. Then only that will be the favored transition state, means less energy. Okay, let me show you the static factor here. Okay, you are given this amine. So what we will do? We will draw the Newman projections. So Newman projections, how to draw? Pay attention, this bond, this carbon bond. Okay, in order to Newman projections formula, to draw the Newman projections, so this carbon and this carbon, this will be my front carbon. So on front carbon there are 3 hydrogen, 1, 2, 3. Okay, 3 hydrogen ache. So in the front carbon there are 3 hydrogen, 1, 2, 3, right? This is the back carbon. In back carbon, how many different groups are there? Okay, 1H, one isopropyl, and one NMe3 plus, right? Okay. If so, in this case, this H and this NMe3 will leave. This H and NMe3 will leave because they are in antipositions. Okay. One more possibility. This H and this NMe3 will leave. So OH minus basically can grab proton from here and double bond formations from here. Okay. So what will happen? In this case, we need to draw the Newman projections formula. So pay attention on this carbon. In this carbon, how many different groups are there? So front carbon, say this is my front carbon. So HMe. So HMe. And this is the back carbon, Me, and one more H is there. So Me, H, and NMe3 plus. Done. Look at these two Newman projections formula. In these two Newman projections formula, basically this is less favored. Can I why less favored? And this is more favored. Can I why? This has less energy, the transition state. And this transition state, less favored, means more energy. Okay, more energy. Can I why? Because of steric repulsions between this CH3 and NMe3, there will be steric clash, and from this NMe3 plus and this CH3 plus, there will be steric clash or steric repulsions. Because of this steric repulsions, this transition state will have more energy, means less favored. In this case, the repulsions is compared to this one, it's a very less, means here this H and this H means minimum repulsions, almost negligible repulsions you can say compared to this one, because this is the bulky group, this is the bulky group, this is the bulky group. That's why transition state will proceed, reactions will proceed, or Hoffmann eliminations will give you the major product through this transition state, not this transition state, because this will have lower energy, and from here you will be getting the less substituted product. You can see that CH2 double bond CHC Me H. One more H will be here. So this is the reason that why less substituted product is the major product, because in the transition state it will have the lower energy because of minimum steric repulsions. Here very high steric repulsions. Okay, done. Next, this is one of the most interesting things, that blindly don't do that Hoffmann product, less substituted product will be the major product. Don't do that. Don't do blindly. What? That less substituted product will be the major product in Hoffmann elimination reactions. Don't do that. It may or may not be. I'll write here, may or may not be. That entirely depend, beta. That entirely depend upon what kind of quaternary amine you were given. See, it entirely depends. Basically, you need to find from the amine most acidic hydrogen, most acidic proton. From that we can easily predict that what will be the major product. Say, look at this amine. So there are two possibilities, two beta hydrogen. So let me write that these are the three beta hydrogens. So this is alpha, this is my beta. So there are two beta hydrogen. So you can write two product, but CH2 double bond CH2 from this side. See, OH minus can grab from this, so double bond will take place, or else OH minus from this side and double bond, and you will be getting, okay, I will be writing better from here, or else you will be getting like this one. So which one will be the major product? See, expected product is this one, but in this case this will be the major product, and this is exceptions to, I will say better that it won't follow the Hoffmann rule. Why this is the major product, this is the minor product? Now let me clear that one. See, if you look at this structure very carefully, you need to find which one will be the more acidic, this one or this one. See, 1 degree and 2 degree, expected that this one will be the less acidic? No, no, no. This is the more acidic compared to this one. In order to explain that one, first you just do this one. Form carbanion here, form carbanion here. Say, if carbanion formations takes place here, so what will happen? This negative charge is in conjugations with this one, benzene ring, pi cloud. So what will happen? This is basically delocalized. This is basically delocalized. Resonance will take place. So delocalizations, delocalizations, delocalizations through resonance, through resonance. And because of that, this conjugate base, I mean very stable, and this is the most acidic hydrogen compared to this one. So in this case, more substituted product will be the major product. Exactly same way we can also do like here. You can check this one. So okay, what you will do? See, this is alpha carbon, this is my beta carbon. Okay, and here this is alpha carbon and this is my, okay, one more. Okay, in this structure basically, okay, let me write this structure once again. Okay, I'll be writing this one. Okay, this is my M, this is M, this is M. Okay, this will be my structure. Okay, this is alpha carbon, this is alpha carbon, this is my beta carbon. Which one will be more acidic, this one or this one? Of course this one. Say, if you form the conjugate base here, this conjugate will be the resonance stabilized, isn't it so? This is the resonance stabilized. Delocalizations will take place. So what will happen? This conjugate will be, base will be the more stable compared to this one. So from here proton won't be grabbed. So proton grab will take place from this carbon. So what you will get? The product, major product, you will be getting like CH3, C double bonded O, CH double bond, CH2. Let me show you that one. Don't worry. Okay, this is my H, this is my H. So OH minus grab proton from here. So double bond takes place here, and okay. So CH3CO, CH double bond CH2, CH3CO, CH double bond CH2. One more product from this side, you will be getting CH2 double bond CH2. So that won't be the major product because this is the more acidic hydrogen. So Hoffmann rule is not always obeyed. सब समय Hoffmann rule करते जाओ ना, माने blindly we can write the product. We need to look at carefully the more acidic hydrogen. That acidic hydrogen will be, more acidic hydrogen will be grabbed by the base. So in this case also the Hoffmann rule is not obeyed. In this case also not obeyed. In this case also not obeyed. Okay. So thank you so much.